Welcome back to the Deep Dive. Today we are embarking on a deep, deep dive into one of history's most compelling figures, but also one of its most, well, historically ambiguous. We're talking about a man whose name has echoed for 2,000 years, a man who went from a Thracian gladiator to a global icon of resistance, Spartacus.
It's just a spectacular story to break down. We've got a fantastic stack of sources here. The classical accounts, of course, but also modern scholarship and analyses of his legacy.
And that's what we want to do, right? Use these sources to triangulate what we can know about the actual man, Spartacus.
Exactly. To examine the sheer terror he inspired in Rome during the war he led, the Third Servile War. And also, to critically assess why his story has been repurposed by everyone from Karl Marx to Soviet sports clubs.
Our mission today is a rigorous one, then. We want to understand the man who terrified the world's only superpower, analyze the military genius he showed with this improvised army of 70,000 escaped slaves. And most importantly, I think, we have to confront the biggest historical challenge right up front. The immense gap between the myth we all know and the man the Romans actually wrote about.
Yes.
And you really have to get this to understand why a conflict that ended in the brutal crucifixion of 6,000 people became known, to some, as the only just war in history.
And we absolutely have to start with that challenge because Spartacus is, globally famous, but he exists almost entirely in a historical shadow. The moment you decide to study him, you have to accept that you're studying Roman perception, not the man himself.
Okay, let's unpack this. Starting with the severe problem of the sources. We're talking about an event that ripped through Italy in 73 BC, right at the tail end of the Roman Republic, probably its most chaotic era. But our main historical anchors, the narratives we really rely on, they were written a century or more later. That's a huge time lapse.
It's an enormous chasm. And that distance in time, in political context, it fundamentally biases our view. Our two primary accounts are from Plutarch and Appian. Plutarch wrote his life of Crassus in the early 2nd century AD. Appian wrote his civil wars a little later. Both of these men were Greeks, writing long after the fact, and they were writing under the stability of the Roman Empire.
So they're looking back at the chaotic final decades of the Republic, but from the comfort of the imperial era. How does that change their perspective on something as terrifying as a massive slave revolt?
It lets them inject moralizing elements, maybe political lessons that might not have been there in the original accounts. They're reconstructing a time of immense instability, civil war, economic upheaval, the very chaos that allowed Spartacus to thrive, but from a position of, relative security.
Okay.
And this is the most critical point for anyone diving into this. Not one surviving source was written by an eyewitness. We have no diaries, no battle plans, no manifestos from Spartacus or his lieutenants.
And certainly nothing from the enslaved people themselves.
Precisely. The voices of the oppressed were completely, utterly silenced. Everything we read is filtered through the lens of Roman officials, generals, or historians who were sympathetic to Rome's need for order.
So we can say what the Romans thought Spartacus wanted.
But we can't know his true objective. That bias is everything.
Which makes the few specific details we do have about his early life even more important, even if they're a little contradictory. So what do we actually know about Spartacus the man before he became, the legend?
Okay, so all sources agree he was a Thracian by birth. He came from an area that today would be near the Strymon River in modern Bulgaria. Plutarch specifically calls him a Thracian of nomadic stock, which might be a reference to the Mede tribe.
And that immediately gives him a background that's not Roman, not Italian. It suggests a certain resilience, a familiarity with hardship, and maybe crucially, fighting outside of standard Roman discipline.
Absolutely. And this is where his military background is so key. Appian says he had once served as a soldier with the Romans, but had since been a prisoner and sold for a gladiator.
Florus says something similar, right? A mercenary.
Yes, Florus calls him a Thracian mercenary who became a Roman soldier, then deserted, was enslaved, and then chosen to be a gladiator because of his strength. So whether he was a mercenary, an auxiliary, or a deserter, the bottom line is Spartacus was a man who understood Roman military tactics.
And their weaknesses.
That experience is fundamental to everything that happens next.
It also humanizes him a bit. I was struck by the fact that Plutarch goes out of his way to mention Spartacus's wife.
He does. He notes that his wife, who he describes as a prophetess of the Mede tribe, was enslaved right alongside him. That small detail suggests he might have been a man of some standing in his own community.
He wasn't just a random peasant.
Right. He brought a spiritual figure with him into the crucible of Roman slavery.
And that crucible was the gladiatorial school, the ludus near Capua, owned by a man named Lentulus Batiatus, and this is where the spark ignites in 73 BC.
Correct. We even know his fighting style. He was being trained as a murmillo.
Murmillo.
Very well.
What does that entail?
Think heavyweight gladiator. Heavily armed, heavily armored. He would have carried a large oblong shield, a scutum, and a short, straight sword called a gladius. That training, which was meant for public slaughter, ironically gave them the perfect foundation for structured combat.
And the escape itself? It's just this perfect story of desperation meeting audacity. It wasn't some grand plan with stockpile weapons, was it?
Not at all. In 73 BC, the plot involved about 70, maybe 78 slaves. And when their plan was discovered, they didn't have swords or spears. They had to grab whatever was in the kitchen choppers, spits, kitchen knives.
70 men, armed with basically large kitchen cutlery, fighting their way out of a professional death school. That says everything about their commitment.
It does. They fight their way out, and then, crucially, they manage to intercept some wagons full of actual gladiatorial weapons and armor.
So they get a real upgrade.
A huge upgrade. They defeat the local soldiers sent after them, and then they make their first really strategic move. They retreat to a strongly defensible, seemingly impregnable position on Mount Vesuvius.
That choice of terrain shows his tactical mind immediately. And once they're there, this leadership structure emerges. We hear about Spartacus and two Gauls, Crixus and Enomus.
Yes, and we need to be a little critical of how the Romans portray this. Roman writers, being intensely hierarchical, they tend to elevate Spartacus as the singular genius. Crixus and Enomus are often reduced to, subordinates or dissenting voices.
But it was probably more of a coalition.
Almost certainly. It was a mixed group of Thracians, Gauls, and others. The leadership was likely more decentralized, reflecting those ethnic loyalties, all just united under this banner of rebellion. Enomus, by the way, seems to have died pretty early on in the fighting.
So if they were such a mixed group, what was it about Spartacus that made the others, especially these Gallic warriors, accept his overall command?
It had to be his competence, his force of will. He quickly proved to be the most capable tactician. And this becomes crystal clear in how the Romans reacted, or rather, how they failed to react.
Here's where it gets really interesting. Because the Roman authorities, they're busy fighting wars elsewhere, and they just dismiss this whole thing. And that initial Roman arrogance, it gave the rebellion the breathing room it desperately needed to grow.
They profoundly underestimated the threat. You have to remember the context. Rome's best legions, its top commanders, they were all overseas. They were fighting the Third Mithridatic War in the East and still dealing with a huge revolt in Hispania.
So a slave uprising in Italy, that's just a local problem.
Exactly. They saw it as a policing matter, a job for the local magistrates, not a full-scale war requiring consular legions.
So they don't send a consul. They send a praetor, a man named Gaius Claudius Glaber, with a hastily assembled militia.
Right.
And Glaber's defeat at Vesuvius is the moment that tells you exactly who Spartacus was as a military leader.
Oh, it's a classic, a textbook example of superior thinking defeating superior numbers. Glaber gets to Vesuvius, and he does the obvious Roman thing. Yeah. He lays siege, he blocks off the main known paths down the mountain, assuming he can just starve them out.
Makes sense.
But he completely discounts the steep, unfortified side of the volcano,
which Spartacus uses brilliantly. It shows his army understood improvisation better than the Romans understood topography.
Exactly. Spartacus's forces use ropes, and not military-grade ropes, but ropes they made from wild vines they gathered and twisted together on the mountainside.
Wow.
And with these, they climb down the steep, almost sheer, unfortified cliff face. It's an incredible feat of engineering and just sheer desperation. They get completely behind the Roman camp and attack from the rear.
Total surprise.
Complete surprise. They overwhelm the mostly untrained militia. And that single tactical victory just changes everything. It screams, this is not a mob of runaway slaves. This is an organized military force led by a genius.
And they followed that up by routing another praetor's forces. The news of these victories must have been a massive recruiting magnet.
It was explosive. The wins legitimized the revolt. Suddenly, slaves, shepherds, rural laborers, they're all flocking to the banner. The sources say the army swelled dramatically, reaching an estimated 70,000 people at its peak.
70,000. That is a massive, spontaneous army operating across Italy. How on earth did they organize that? And how did they maintain military effectiveness when they were made up of so many different groups?
I think it comes down to two crucial factors that people often overlook. First, most of the recruits were rural slaves, the ones working the brutal latifundia, the largest states.
So they were already hardened.
Exactly. They were already used to brutal physical labor, long marches, and surviving in the wild. They were far better prepared for campaigning than, say, urban household slaves.
So their entire life was already a form of extreme training.
Precisely. The second factor is the presence of legion veterans in their ranks. The Republic had just finished the Social War, a massive conflict where Rome fought its Italian allies.
Ah, okay.
So a lot of former soldiers, allies, mercenaries, people sold into slavery after the conflict, they had institutional knowledge of Roman discipline, formations, logistics.
That's the game changer. So Spartacus, a former soldier himself, now has a core of experienced people who can translate his tactics into workable structures for 70,000 people. And they spend the winter of 73, 72 BC doing what?
Not resting. They were actively training, arming, and equipping all these new recruits. They expanded their raids, securing supplies from wealthy towns like Nola and Thurii. And the spread of these raids shows they were already operating in two main independent groups, commanded by Spartacus and Crixus. That points to complex logistics.
By the spring of 72 BC, the Senate finally has to admit this is a full-blown war, the Third Servile War. They stop sending militias, and they dispatch the highest commanders they have available. 2 consuls, each with 2 legions.
This was the official recognition of failure. This was the best the Republic could muster at the time. But the initial results were actually disastrous for the rebels.
Right, Crixus's group is defeated.
Yes. The consuls catch Crixus's group, maybe 30,000 men, near Mount Garganus, and Crixus is defeated and killed.
That must have been a crushing blow. Losing a key leader, losing that many men. The Romans must have thought the rebellion would just collapse.
They absolutely did. But this is where you see the genius of Spartacus. Instead of collapsing, he takes the strategic initiative. He then defeats the combined consular legions when they link up, turning a Roman victory into yet another massive humiliation.
Unbelievable.
The Roman accounts disagree on the exact details, but the final result is undeniable. The Republic had been militarily humiliated by a former gladiator.
So after this huge success, they've beaten the consuls, they've basically cleared a path north over the Alps, out of Italy, and then they turn south again. This turn south is one of the biggest mysteries of the whole war, isn't it?
It is the central question. Why abandon what looks like freedom and march back into the heart of Italy, potentially trapping yourself?
And the sources just don't agree.
They're completely divided. Plutarch is the main one who argues Spartacus's goal was always escape. He wanted to get his people over the Alps and back to their homelands in Gaul or Thrace. If that's true, the turn south is just. It's an inexplicable blunder.
But then you have Appian and Florus who suggest something much bigger.
Exactly. They imply he wanted to march on Rome itself. Now, a direct assault seems suicidal, but the turn south could be seen as a way to, I don't know, seize more plunder, secure supplies for the winter, maybe gain some political leverage before trying to leave.
It also seems likely the army itself wasn't unified. Didn't Crixus's faction, the Gauls and Germans, want to stay and plunder Italy?
That's a key part of the modern analysis, this internal friction. Spartacus's faction perhaps wanting a strategic retreat, and the Gallic and Germanic faction being more motivated by revenge and wealth. That could have been the deciding factor. Spartacus might have been forced south by pressure from within his own ranks.
Which makes the army less of a unified force and more of a fragile coalition. But whatever the reason, that decision to stay in Italy sealed their fate, because it forced Rome to escalate. They finally bring in the big guns. Marcus Licinius Crassus,
the wealthiest man in Rome. He volunteers for the command, seeing it as a massive political opportunity. And the Senate gives him an enormous force. 8 legions. You're talking about upwards of 40,000 trained Roman soldiers.
And Crassus sees right away that the problem isn't just Spartacus, it's the morale of the Roman army after all these defeats. So to fix that, he brings back a punishment so terrifying, we still talk about it. Decimation.
It's a truly chilling detail. Decimation had been rarely used. It involves executing 1/10 of a unit that performed poorly. The soldiers were chosen by lot and then beaten or stoned to death by their own comrades.
Why? Why do that to your own men?
Because the Roman troops were no longer afraid of the slave army. They had low morale. They were disobedient. Crassus's goal was pure psychological warfare. He had to make absolutely sure his soldiers were more afraid of him than their enemy.
And that brutality. It worked.
It did. After that, Crassus's legions operated with this new, terrifying discipline. He gains the upper hand and starts pushing Spartacus further and further south toward the toe of Italy, a place called Rhegium.
Spartacus must have seen he was being driven into a trap. He was aiming for Sicily, right? hoping to stir up more revolts there.
He was desperately trying to get off the peninsula. Plutarch says he made a deal with Cilician pirates to ferry 2,000 of his men across the Strait of Messina to Sicily.
But the pirates, being pirates,
They delivered a crippling betrayal. They took the payment, probably a massive amount of plundered gold and silver, and then they just sailed away. They abandoned the rebels completely.
which left Spartacus's best escape route gone.
Totally gone. And Crassus, who was a master of logistics, immediately capitalized. He built this massive system of fortifications across the entire isthmus at Rhegium, a 12-mile-long ditch and a rampart sea to sea.
So he just trapped the entire rebel army.
Completely cut them off, besieged them, started starving them out.
It seems like a perfect slow-motion victory for Crassus. But then Roman politics throws a wrench in the works. Crassus suddenly has to speed things up.
That speed comes from his old rival, Pompey the Great. Pompey's legions are returning from Hispania, and the Senate, maybe not fully trusting Crassus, orders Pompey south to help out.
And Crassus knows what that means.
He knows Pompey might sweep in, fight one battle, and steal all the credit. So, fearing that political humiliation, he rejects Spartacus's desperate attempts to negotiate a truce. He needs a quick, decisive battle.
And Spartacus is forced into one last desperate move.
He manages to break through Crassus's fortifications, takes heavy losses, and makes a break for Brundusium on the eastern coast, probably hoping to find ships. But during that march, the discipline of the rebel army finally breaks.
They start splintering.
Exactly. Smaller groups break off, engage the legions on their own. It fragments the army. It forces Spartacus to turn his entire remaining force around for one final unified stand.
Which brings them to that last crushing battle in 71 BC near the Sele River.
All the sources agree it was a complete rout. The rebels were annihilated. And yet, for all the detail, the fate of the leader himself remains this huge historical mystery. Plutarch, Appian, Florus, they all say Spartacus died fighting bravely.
What?
But Appian explicitly says his body was never found.
The vanished body of the rebel leader. That absence is almost as powerful as his actions because it leaves the door open for mythology. But the vengeance Rome took was terrifyingly real. It was a message.
Unparalleled brutality. Crassus rounded up 6,000 captured survivors and ordered them crucified. They lined the Appian Way, the main road south from Rome, all the way back to Capua, where it all began.
A spectacle of death stretching over 100 miles.
A gruesome warning meant to ensure no one ever forgot the price of rebellion.
It's a chilling image, and it really shows how deeply Spartacus had terrified the Republic. Which brings us really to the core of this deep dive. With this historical vacuum, this uncertainty about his motives, how did his memory become such a potent, adaptable symbol?
Well, that mystery of the turn south is directly linked to the debate on his motives. And that debate feeds the legend. You have Plutarch saying he just wanted to escape, and Appian and Florus suggesting he might have aimed for Rome. That vacuum allows for projection.
And what we as modern listeners often assume, based on the narrative, is that he wanted to abolish slavery itself.
That's the powerful modern myth. But this is the crucial historical point we have to make. The ancient sources do not support the idea that Spartacus aimed to reform Roman society or abolish slavery as an institution.
Wait, so if he wasn't a proto-abolitionist, what do the sources actually suggest his goal was?
The goal, based on his actions, plundering, moving, avoiding long sieges, it seems to have been about survival, getting material gain for his followers, and securing their personal freedom by getting out of Italy.
But he freed thousands of slaves.
He freed rural slaves who were easy to extract and were good fighters, but he seems to have consciously avoided recruiting the more numerous urban slaves. If your goal is total revolution, would you want to destabilize the cities? But if your main goal is to form a mobile, effective army that can cross the Alps, recruiting thousands of household cooks and tutors would just be a logistical nightmare. The absence of abolition as a stated goal in any classical account is very telling. It suggests the legend that grew up around him completely eclipsed his actual, probably more practical objectives.
So the legend had to create a revolutionary out of a resourceful gladiator. And that legend became incredibly potent in the modern era, especially for communists and socialists.
Oh, his story was perfect for 19th and 20th century political philosophy. The enslaved worker rising up against the wealthy landowning oligarchy, Karl Marx was utterly captivated. He called Spartacus the most splendid fellow in the whole of ancient history, a real representative of the ancient proletariat.
That is a staggering leap. From a Thracian mercenary fighting for his life to the ancient symbol of the global working class. That political repurposing is what made him immortal.
It truly is. And the symbols spread everywhere. In the 18th century, he inspired Toussaint Louverture, the leader of the Haitian Revolution. Louverture was called the Black Spartacus.
And in 20th century Germany,
He inspired the German Spartacus League, founded by Karl Liebknecht and Rosa Luxemburg. They were the forerunners of the German Communist Party, and their failed revolution in 1919 is known as the Spartacist Uprising. His name just became a shorthand for violent resistance.
but the legacy wasn't just political, it became institutionalized in sports and culture, especially in the Soviet bloc.
This is where his name becomes pervasive in Eastern Europe. The Spartakiad was the massive Soviet version of the Olympics, meant to counter the so-called bourgeois nature of the real games.
So they turned the revolutionary into a symbol of collective physical prowess and national unity, which is a fascinating rebranding of a man who fought for individual freedom from the state.
It is, and that name is still everywhere in sports clubs today. FC Spartak Moscow, one of Russia's biggest football clubs. HC Spartak Moscow. In ice hockey, you find Spartak clubs all over Ukraine, Bulgaria, Slovakia. The name just signifies strength and defiance.
And for most of us in the West, we probably know the name from the 1960 Kirk Douglas movie.
The Stanley Kubrick film, yeah. And that film is a perfect example of the legend eclipsing the history. It heavily romanticized the idea of a fight for universal abolition, which fit perfectly with Cold War liberal ideals.
So really, what does this all mean for us today? The fact that his history is so uncertain, we don't know his true motivation, we don't know where his body is, that allows his story to be endlessly repurposed. He's a blank canvas for resistance.
That is the ultimate takeaway. The historical man was a brilliant, pragmatic military leader who terrified Rome. He forced the Republic to deploy its wealthiest general and use its most brutal tactic decimation, all to stop a rebellion that started with 70 guys and some kitchen knives. The sheer extremes Rome went to tells you everything about the threat he posed.
And maybe the real lingering tragedy here is the silence. We are left only with the Roman accounts, the accounts of the victors. The philosopher Voltaire once described the Third Servile War as the only just war in history.
And if you accept that, you have to then wrestle with the painful irony that the full history of this only just war is told entirely by the side that waged the unjust war against it.
We're just left to wonder what the real motivation was, what a true slave commonwealth might have looked like if the voices of Spartacus, Crixus, and the 70,000 who followed them had survived, instead of being extinguished on the Appian Way. It's a powerful, unsettling thought. We really encourage you to look up those cultural references, especially the Soviet-era sports connections. The depth of the legacy is incredible.
Dive deeper into those sources yourself.
That was the deep dive. We'll see you next time.
Welcome back to the Deep Dive. Our mission here is to take the sources you share with us, filter out all the noise, and really just deliver the critical insights you need to be well-informed and fast.
And today we're cracking open a concept that I think everyone feels like they know, the scientific method.
Right?
It's that rigid 5-step recipe most of us were handed in school. Observation, hypothesis, experiment, conclusion.
The flowchart.
Exactly, the flow chart. It's always presented as this very clean, very sequential path for how science is supposed to work.
And if you stop there, you miss, you miss everything. The sources you send over make it really clear that the reality is just so much messier.
Oh, absolutely.
It's highly iterative.
Yeah.
And it fundamentally relies on, actual human intelligence, imagination, and a massive dose of creativity. It's not just a strict unthinking recipe.
Right. And so this deep dive is really your shortcut to understanding those philosophical foundations and all the varied, sometimes contradictory methods that really make up scientific inquiry today.
So let's start with the core identity. What is it at its heart?
Well, since about the 17th century, the core idea has been that it's an empirical process for acquiring knowledge. It all comes down to rigorous skepticism, extremely careful observation, and then systematically testing ideas.
And of course, validation through evidence.
Exactly. But what I think makes this method so potent is its radical self-awareness. It starts from the assumption that our own cognitive biases,
The things that make us human.
right, those things can and often do distort how we interpret what we see. So the method is, in a lot of ways, a system built to fight our own minds.
In a system like that, a self-correcting one, it must have taken millennia to develop.
It did. We often think of this as a purely modern thing, but the sources show us that the roots of this kind of rigor, they stretch back incredibly far. You can trace lines of thought to the ancient Greek Stoics.
With their emphasis on logic and methodical observation.
And Aristotle, of course. His work really laid the groundwork for systematic classification.
But there's a piece of historical context that often gets glossed over, and that's the critical role of the Islamic Golden Age. We're talking about thinkers like the 11th century polymath Alhazen.
Yes, he is often called the father of optics, and for good reason.
What was his big contribution?
Well, Alhazen didn't just observe. He established the vital importance of testing theories experimentally. He really formalized this process of combining observation with controlled experiments, which was a huge leap beyond the pure thought experiments that some of the earlier Greek scholars favored.
And he wasn't alone.
Not at all. You have someone like Avicenna in his Canon of Medicine who detailed these really rigorous requirements for how to conduct medical trials. He was emphasizing the need for controlled conditions, for ruling out bias. I mean, these are fundamental shifts toward modern empiricism.
So the practice of scientific inquiry is ancient, but the actual term, the scientific method, that only came into popular use in the 19th century. Why? Why the big delay?
That delay lines up almost perfectly with the institutional development of science itself. As fields started to professionalize and researchers began specializing, there was a real need to, define the boundaries.
To build a fence around what science was.
Precisely.
Right.
The method became a shared standard, a gatekeeper, really. It was used to define what a scientist was, and maybe more critically, to separate legitimate inquiry from what was then getting labeled as pseudoscience.
Okay, so let's unpack this iterative cycle. Let's move from that simple textbook ideal to the working reality. The textbook version is rigid, but the operational schema scientists actually use it's a lot more dynamic. It's often generalized into about 8 steps.
And we should really emphasize that this is a guideline, right? It's not a sequential list you have to check off.
Not at all.
It's more of a pragmatic map. You start by 1, defining a question or identifying a problem. Then 2, you gather existing info, you do some initial observations. 3, you form your hypothesis.
Your best guess.
Your best reasoned guess. Then step 4 is testing that hypothesis, usually with an experiment, and collecting data. 5 is analyzing that data. 6 is interpreting it, drawing conclusions, and this is key. That often leads to refining your idea or even forming a completely new hypothesis.
And then 7 is publishing your work.
And then step 8, which is maybe the most important part for scientific rigor, is retesting, the replication of the results by other people.
What's really essential for you to get here is that the cycle doesn't just go in a straight line. It loops back on itself all the time.
Right. It's not just from conclusion back to a new hypothesis. Sometimes you get new data and you have to go all the way back to redefining the original question. Or maybe you realize you need to gather more foundational information. It's not a line, it's a spiral of refinement.
So those 8 steps are the big picture. But if we distill the whole process down, philosophers of science tend to agree on 4 core components that have to be there for any inquiry to be, meaningful scientific.
The first component is characterizations. This is all about meticulous observation, developing really clear definitions and careful measurements of whatever it is you're studying.
And this stage is just so vital because the entire framework, everything else you do, it rests on the accuracy of what you're measuring in the first place.
That's a great point. The sources highlight that the quality of this stage is often what separates true science from more speculative fields. I mean, think about what separated alchemy from chemistry.
It was the systematic collection of measurements.
Exactly, that rigorous, organized approach. And it's crucial that scientific definitions are precise. We have to distinguish between, say, common usage and a technical definition, like the example of mass versus weight.
In everyday conversation, they're the same thing.
Right, interchangeable. But in mechanics, mass is an intrinsic property of an object, while weight is the force exerted on it by gravity. That precision is everything, and it often requires specialized instruments, whether it's a simple tool or a massive device like a particle accelerator.
Okay, so that's component 1. The second is hypotheses. These are the suggested explanations, the reasoned proposals, and they often take the form of these predictive mathematical models.
And the single most discussed feature of a hypothesis, thanks to the philosopher Karl Popper, is its falsifiability.
The ultimate filter.
It really is. Falsifiability just means that there has to be a conceivable experiment or an observation that could potentially prove your hypothesis wrong. It has to conflict with the predictions.
So if a hypothesis is so vague or so flexible that it can explain every possible outcome after the fact,
Then it's not testable. And in a rigorous sense, it's unscientific.
so a theory that says the stock market will go either up or down tomorrow is useless. It risks nothing. A real scientific hypothesis has to take the risk of being proven wrong.
Precisely. And this leads right into the third component, predictions. These are the logical consequences that you derive from your hypothesis, usually through deductive reasoning.
And there's a critical rule here: novelty.
Yes. The outcome of testing this prediction must be currently unknown for a successful result to actually increase your confidence in the hypothesis.
Why is that so important?
Because if we already know the result, it was probably factored into how you formed the hypothesis in the first place. So all you're doing is demonstrating internal consistency, not actual predictive power.
Okay, and that brings us to the fourth component: experiments. The actual systematic test designed to seek out those novel predictions. This is where you really have to deal with observational error.
This is where a concept you brought up earlier, Mill's canons, becomes so important. These are fundamental methods for inductive inference from the philosopher John Stuart Mill.
So when we talk about experimental control, we're often talking about applying these ideas.
Specifically, the method of difference, which basically means that if you have two situations that are identical in every single way except for one variable,
That's one.
just one, and a phenomenon occurs in a situation where that variable is present but doesn't occur where it's absent, then that single variable is the cause, or at least a necessary part of the cause.
So experimental control is all about isolating variables.
It is. It's about providing a contrast between multiple samples under different but controlled conditions. That isolation is how we fight observational error and demonstrate genuine correlation, or ideally, causation.
That breakdown of the four components really helps you appreciate how complex this iterative engine truly is. And to see it in action, let's look at the discovery of the structure of DNA. It perfectly illustrates this messy, spiraling cycle.
The starting point, the initial characterization, was really set by the mid-20th century. Gregor Mendel's work had established the laws of inheritance, and by 1944, Oswald Avery had shown that DNA carried the genetic information. The central unsolved problem was how. How is this incredibly complex information physically stored and then replicated?
And this uncertainty created space for several hypotheses. The famous chemist Linus Pauling, based on his own data, proposed a triple helix structure for DNA.
It was a highly plausible hypothesis, but it was also wrong. And what's interesting is that Francis Crick and James Watson were able to discard Pauling's structure almost immediately, based on existing knowledge. They knew DNA was an acid, which meant its phosphate groups should be ionized, negatively charged.
And in Pauling's structure,
He put those groups close together at the core of the helix, which would have meant they had to be unionized. A molecule with that many negative charges packed so tightly would immediately repel itself and just fly apart.
so an error in one crucial piece of characterization data let them eliminate a leading hypothesis right off the bat. The process works because you're constantly cross-referencing against what's already known.
Exactly. So the next major phase involved a critical piece of observation and prediction, and this was driven by Rosalind Franklin's work. When Watson saw photo 51, her famous X-ray diffraction image, it was an instant breakthrough.
Why was that X shape so important? What did it show?
Because that specific X-shaped pattern was the prediction implied by something called the Cochran-Crickvan-Stokes theorem. It's a mathematical description that says diffraction from any helical structure produces that exact X-shaped pattern.
So it didn't solve the structure.
No, but it confirmed a major structural constraint. It had to be a helix.
This is where the ingenuity and the iteration really kicks in. They realized that trying to solve this with more, highly theoretical math was going to be way too slow.
So they shifted their approach. They started building physical models based on empirical constraints.
And this meant using previously characterized data, right? Like Chargaff's rules.
Right. Erwin Chargaff had shown that the amounts of adenine, or A, and thymine T were always equal. Same for guanine G and cytosine C. But even with those rules, their first models just wouldn't fit together.
The breakthrough came from correcting another piece of characterization data. Their colleague, Jerry Donahue, he told them the standard textbook diagrams of the base pairs were actually wrong.
They were using what's called the enol form, but the molecules actually exist in the keto form. The difference is subtle. It's just about where the atoms are placed, but it's fundamental. It changes where the hydrogen bonds can form.
And when Watson and Crick used that corrected keto form in their physical models,
Everything clicked. They realized that an adenine-thymine pair held by 2 hydrogen bonds was identical in shape and size to a guanine-cytosine pair held by 3.
and that physical fit was the final piece of the puzzle. The elegant, self-consistent double helix structure. They went from defining a problem to refuting a bad hypothesis to confirming a prediction from physics and then iterating rapidly with physical models guided by corrected data.
And their final paper, which was only about 900 words, it concluded with the ultimate scientific prediction. They wrote, "It has not escaped our notice that the specific pairing we have postulated immediately suggests a possible copying mechanism for the genetic material."
Wow.
The structure itself screamed function, and that kicked off the next massive cycle of inquiry in biology.
The DNA story really showcases the process, but what keeps that process, honest
Yeah.
and reliable? Our sources stress these foundational principles, striving for accuracy, honesty, openness, and above all, rigorous skepticism.
And at the heart of that skepticism is falsifiability. We mentioned Karl Popper and his insistence on this as the sharp line of demarcation between what is science and what is not.
Let's dig into that a little deeper. How does Popper's idea help you differentiate between a truly scientific theory and one that's just comprehensive?
Okay, think about psychoanalysis versus general relativity in Popper's framework. According to Popper, psychoanalytic theories were constructed in a way that they could explain any human behavior.
Right. No matter what a person did, the theory could explain it after the fact.
Exactly. It's a retroactive explanation machine. If a theory explains everything, it predicts nothing specific, and so it can never be refuted.
Contrast that with Einstein.
Einstein's theory of general relativity made a very specific, very high-risk prediction. That light from distant stars would be deflected by a measurable amount when passing close to the sun. If the 1919 solar eclipse observation had shown no deflection,
The theory would have been falsified.
it would have been proven false. It took the risk of being wrong, and that, for Popper, is what made it truly scientific. The value of a theory is its willingness to expose itself to being refuted.
But science also has to deal with this built-in human limitation, the observation paradox or theory latentness.
This is a huge concept for you to get. The limitation is simple. There is no such thing as pure, uninterpreted observation. Any data we gather requires a prior theoretical framework, a set of concepts, just to be understood.
So what you observe is inherently influenced by what you already believe.
That's it. The classic example is the rivalry between the astronomers Tycho Brahe and Johannes Kepler. They were looking at the exact same sky, the same celestial bodies, but they drew radically different conclusions.
Because their prior theories were different.
Completely different. They both observed the sunrise. Brahe was working with a geocentric model. He thought the Earth was the center. And because of that, he missed certain optical facts. He actually concluded it would be impossible to ever see the solar corona during an eclipse.
But Kepler, working with a sun-centered model, he interpreted the same visual data differently.
Right. Kepler was already thinking about optics and geometry, and he correctly deduced that the size of the viewing aperture controlled the sharpness of the image. A basic fact of optics now. Brahe missed that because his conceptual framework wasn't even looking for that kind of problem.
So this complexity means our tools for reasoning, for scientific rationality, they have to be robust enough to handle data that might be biased by our own theories. Which brings us to induction and deduction.
Right, the two primary justifications for truth. Inductive reasoning is building general principles from lots of specific observations. If you see 1,000 swans and they're all white, you induce the general principle all swans are white.
The conclusion is probable, but it's never guaranteed. All it takes is one black swan to disprove it. So induction is really used to generate hypotheses, to spot patterns.
Exactly. And conversely, deductive reasoning works by deriving specific conclusions from established general principles. If premise 1 is all men are mortal and premise 2 is Socrates is a man, then the conclusion Socrates is mortal must be true.
As long as the premises are true.
Right, and deduction is used to test hypotheses by figuring out their specific logical consequences.
The history of gravity is a perfect illustration of how these two work together. You have thousands of years of astronomical data collected by, the Chaldeans, the Indians, the Greeks. That was just massive scale inductive data collection. pure observation.
And that inductively gathered data is what allowed Kepler to formulate his 3 laws of planetary motion. They were general principles based on empirical patterns.
And then a few decades later, Isaac Newton used deductive reasoning to unify all of it. He used his general principles of motion and gravity to deduce the specific motions that Kepler had observed.
But the cycle doesn't stop. In the 19th century, astronomers noticed that Mercury's orbit didn't quite match Newton's deduction. That observation, that counterexample, proved Newton's theory was incomplete.
And that pushed Einstein toward his general relativity calculations, which matched the observation much more closely.
And that's the messy spiral in action. A failure in deduction forces new observation, which leads to a new wave of induction, which generates a more robust theory.
Speaking of human flaws,
Yeah.
scientific methodology has to constantly fight personal bias, especially confirmation bias, our tendency to see what we expect to see.
It's a huge risk, especially when observation is so theory-laden. We're wired to favor evidence that confirms what we already believe. That's why the methodology demands testing under highly controlled conditions to try and diminish those effects.
There's a wonderful visual anecdote for this, the historical belief in the flying gallop.
Oh, I love this one.
For centuries, artists depicted galloping horses with all 4 legs splayed out in midair, because that's what the human eye thought it saw. Is what people expected to see during the fastest part of the stride.
It was a powerful, centuries-long confirmation bias, reinforced by art. And it took a rigorous, dispassionate experiment, specifically Eadweard Muybridge's stop-action photography in 1878, to finally kill it.
His photos showed definitively that when a horse's legs are all off the ground, they're actually gathered up underneath its body, not splayed out.
The empirical fact, provided by a technological experiment, completely invalidated a powerful human assumption.
So we've established the method is iterative, it's flexible. Let's explore the actual variation scientists use, moving beyond that simple 4-part cycle to look at specific frameworks for inquiry.
The most traditional framework, and one we've kind of touched on, is the hypothetico-deductive method, or HD method. It's hypothesis first. It relies on deductive reasoning to test that hypothesis. But crucially, it doesn't test the theory itself directly.
It tests the implications of the theory. Okay, what does that mean for how certain the conclusion is?
It means we're relying on a specific logical structure called modus tollens. If theory A implies implication B, and we find out that implication B is false,
then theory A must also be false.
right, it's valid deductive logic. The test refutes the theory, but the reverse logic doesn't work.
Meaning, if implication B is found to be true, it doesn't necessarily prove theory A is true.
Exactly. It only provides support or confirmation for theory A. It doesn't prove it because there might be some other theory C out there that also implies B. This is why Popper was so fixated on falsifiability. Successful tests can build confidence, but they never give you absolute certainty.
Okay, so moving away from that hypothesis-first approach, we have the inductive method, which has seen this huge resurgence lately with big data.
Right. This is a data-driven approach. It focuses on formulating a research question, collecting a massive amount of data, and then letting the knowledge arise inductively after you have the data. You let the patterns in the data speak for themselves.
What's the main advantage of going data first like that?
It's praised for being theoretically neutral. By not starting with a specific hypothesis, you can diminish the risk of confirmation bias. You're allowing patterns to emerge that no one might have preconceived.
And third, we have mathematical modeling. This involves creating an abstract construct that you can test instead of a physical experiment. The sources call this allochthonous reasoning.
Allochthonous just means originating in a different place. So the reasoning originates in the mathematical construct, not the physical world. It uses simplification and abstraction to create a usable model.
So the math model becomes the lab, and then you need a way to translate the results from that lab back to reality.
Right, and those are the correspondence rules. They translate the mathematical results back to observable phenomena. The strength here is its power in really complex systems where a physical experiment might be impossible or just way too expensive.
Now, all of these different variations, HD, induction, modeling, they all lead to this core philosophical question that really shook things up in the mid-20th century. Is there even a scientific method?
This is the real aha moment for a lot of people because the idea that there's one universal method was profoundly challenged. Thinkers like Thomas Kuhn started questioning whether science really progressed smoothly using a single unified method at all.
Right, his work on paradigm shifts. He suggested that science operates within these established frameworks or paradigms until a crisis forces a revolution.
Hmm.
And if the methodology changes between paradigms, how can there be one single method?
And this philosophical conflict really boiled down to two camps, unificationists and pluralists. Unificationists argued for a single, useful definition of method that could apply across all the sciences.
But pluralists looked at the sheer variety of how science is actually done, all the different methods used in different labs, and they just rejected the idea that one universal definition could ever be useful. Science, they argued, is just too diverse in practice.
And out of this discourse came the most radical critique of all, from Paul Feyerabend. He called it epistemological anarchism.
Anything goes. That's his famous line from Against Method.
That was his joking suggestion for the only universally valid rule. He argued that if you look at the history of major breakthroughs, you'll find there are no universal, exception-free methodological rules. He claimed that scientific progress often relied on violating the established norms.
He basically said that insisting on one rigid method would only stifle creativity and innovation.
Exactly. Now, that sounds dangerous, right? We want innovation, but we can't just let scientists throw out all the rules.
So how do you balance that? The need for radical innovation with the need for reliable evidence.
That is the critical tension. And while Feyerabend really championed the role of violating norms, the consensus remains that skepticism and prudent management are still essential. But his great contribution was to permanently undermine the belief that the textbook recipe was an accurate picture of scientific reality.
So if we synthesize this whole debate, the singular sequential scientific method that's taught in high school is, well, it's widely seen by historians and philosophers of science as a myth, or at least an idealization.
It serves a purpose. It's a communication tool in education. It sets out ideals of rigor and honesty. But it just doesn't reflect the messy, local, and flexible way scientists actually work.
If the method is so fluid, how do scientists choose between competing hypotheses, especially when the evidence might be limited? This is where heuristics come in, these guiding principles, rather than hard and fast rules.
Heuristics are crucial for the human side of science. We need ways to decide which theoretical path is the most fruitful to pursue. Thomas Kuhn identified several, but we can focus on three really essential ones.
Starting with the classic, parsimony or Occam's razor.
Parsimony just recommends the simplest explanation when the data supports multiple ideas equally well. Isaac Newton put it very clearly. We should admit no more causes than are both true and sufficient to explain their appearances.
So if you have two theories explaining planetary motion, you choose the one with the fewest unsupported assumptions.
That's the idea. But it's not always about starting simple. The economist Paul Krugman once advised researchers to dare to be silly first, to broaden their theoretical view before trying to simplify. So you often start with a bunch of messy ideas and then use parsimony as a filter to select the most economical model.
Okay, next up we have elegance. That definitely sounds subjective.
It is, but it often describes a theory that has a kind of deep symmetry and simplicity, and it avoids being jammed with fudge factors.
Duck factors.
Those are the arbitrary corrections or parameters you add just to save a failing idea from being refuted. An elegant theory doesn't need them. But the danger is that relying too much on what feels aesthetically pleasing can prevent a breakthrough into a new, maybe uglier, but more accurate paradigm.
And finally, a concept that became really powerful after Einstein. Invariance.
Invariance is the idea that good scientific structures are independent of your perspective. It gained a lot of weight because Einstein's theories reduced physics to these fundamental relationships that were unchangeable, regardless of the observer's motion or position. The physicist David Deutsch called these hard-to-vary explanations.
Can you give us a concrete example of that?
Sure. Think about the equivalence principle in general relativity. The idea that gravitational mass and inertial mass are the same thing. Einstein used a thought experiment of an observer in a windowless elevator in deep space.
Okay.
If the elevator is accelerated uniformly upward, the observer inside feels a force pressing them down, which is indistinguishable from gravity. The physical laws are invariant. That powerful invariant observation was a key argument for equating the two types of mass, something Newtonian mechanics couldn't explain.
We focus so much on rigorous methods, but we have to acknowledge the role of chance, or serendipity in discovery. Science isn't always a linear pursuit.
Not at all. Some estimates suggest that between a third and a half of all scientific discoveries are stumbled upon, not sought out. Alexander Fleming's discovery of penicillin is the classic case. He left a bacteria culture plate uncovered, it got contaminated by mold, and he just happened to notice the bacteria died off around the mold. He wasn't looking for antibiotics.
Louis Pasteur famously said serendipity favors the prepared mind. But what does that preparation actually look like?
Well, the psychologist Kevin Dunbar studied how scientists actually work, and he found that the discovery process often starts when researchers find bugs in their experiments, unexpected results that contradict what they thought would happen.
So most researchers would assume they just messed up the experiment.
Right. They try to fix their technique. But the prepared mind is the one that recognizes the error is too persistent, too specific to be a coincidence. The scientific method's emphasis on control and careful documentation actually helps researchers spot these systematic errors and realize they might be a new phenomenon.
That's interesting. The rigor actually makes the system more open to unexpected results.
Exactly. It makes it anti-fragile.
Now, speaking of rigor, we should address some modern limits, particularly the challenges posed by statistics.
This is a major contemporary crisis in science. John Ioannidis' 2005 paper, Why Most Published Research Findings Are False, was foundational for the whole field of metacidence. He showed that findings are less likely to be true when studies are small and when there's a lot of flexibility in how the study is designed and analyzed.
So what does that mean for you, the listener?
It means you have to apply critical scrutiny. When you read a headline about some small nutritional study that seems counterintuitive, remember Ioannidis' logic. If the initial probability of a finding being true is already low and the study is small, the reported results are likely false, or at least impossible to replicate.
And finally, how does this classic scientific method cope with genuinely complex systems and big data?
It's difficult. Applying the method stringently to interconnected systems like climate science or genomics is tough because you can't really isolate variables. And with big data, there's a risk that data might get stripped of its context, of the rich variables you need to formulate and test alternative hypotheses. If the data is only used to support one predetermined idea, it undermines the whole function of skepticism and falsification.
So our deep dive really confirms it. The linear recipe we learn in school is just an idealization. The true scientific method is a flexible, iterative, and critically self-correcting cycle.
Its strength isn't in following rigid rules, but in adhering to these core principles. Rigorous skepticism, the insistence on falsifiability, and that continuous messy balance between observation and theoretical reasoning.
It's a very human process. It thrives on intelligence, imagination, iteration, challenge, and even chance.
It's a process where confirmation by a collective of prepared minds is necessary for an idea to be accepted, but where innovation is often sparked by someone violating the norms or just by sheer luck.
To leave you with a final provocative thought, the philosopher Imre Lakatos argued that in non-axiomatic math, no theorem is ever truly final. A mathematical conjecture is only considered true until a counterexample is found, forcing continuous revision through contradiction and refusal.
So think about that. If even the fundamental conjectures of mathematics, the very language physics and chemistry are written in, are subject to this constant state of revision, how should that unfinality impact how you view established scientific facts in your daily life? The strength of a theory isn't really measured in its certainty. It's measured in how long and how successfully it has persisted, facing down challenges and counterexamples without major changes to its core ideas. That enduring quality is the true power and the humility of science.
Okay, let's unpack this. For decades, we have been running deep dives into the question of unidentified aerial phenomena, or UAPs.
Right.
We've looked at everything from, advanced Soviet military programs and novel atmospheric physics to the more traditional explanations.
Extraterrestrials, interdimensional beings, that sort of thing.
Exactly. But today, we're tackling what might be the most radical and maybe the most human possibility of all.
It's the ultimate twist, isn't it? The premise we're diving into is the time traveler hypothesis, or TTA.
And what's the core idea?
The proposal is that these advanced, often baffling crafts, the ones seen executing impossible maneuvers in our skies, they're piloted not by entities from distant star systems, but by humans who have traveled back in time from our own far-flung future.
It sounds like a premise straight out of Hollywood.
Oh, absolutely. And it's earned a set of nicknames that really reflect that drama.
Like what?
Well, you hear it called the chrononaut UFO theory, the future humans model.
And sometimes, with a distinct sci-fi flair, the Terminator theory.
Yeah, that one implies they might be here for more than just a historical tour.
And as the hypothesis has gained a bit more traction, we're seeing more formal, almost academic terms for it.
That's right. The main one is the extratempestrial model. It's a neologism, a new word, coined by biological anthropologist Dr. Michael P. Masters.
And that term, extratempestrial, it's meant to provide a sort of scientific framework for analyzing what these future humans might actually look like, right?
Exactly. It moves the conversation from pure sci-fi into speculative science.
The fact that we even have an academic framework for this tells you something about its recent exposure. I mean, this isn't strictly confined to online forums anymore.
Not at all. We've seen people of real stature, people you really wouldn't expect, giving this concept public oxygen.
Like who?
Well, consider retired NASA aerospace engineer Larry Lemke. He openly discussed the hypothesis. And then you have Wisconsin Congressman Mike Gallagher suggesting publicly that UAPs could be us from the future.
And maybe the biggest mainstream exposure came from filmmaker Steven Spielberg.
Huge exposure. He openly speculated on it, asking the question, what if it's us 500,000 years in the future?
That kind of high-profile mention, it just elevates the conversation immediately, doesn't it? It moves it past just the fringe.
It does. But before we get too excited about our time-traveling descendants, we need a reality check.
Okay, so what is the current status of the time traveler hypothesis in, say, academic circles?
The status is pretty clear. Despite that high-profile exposure, the TTH is considered extremely implausible by mainstream scholars.
And even within the traditional UFO community.
Even there, where you'd think they'd be open to wild ideas, this specific hypothesis is regarded as unorthodox.
Why is that?
Most traditional theorists just find the mechanisms of time travel too difficult to support. They prefer the extraterrestrial or interdimensional explanations. They're, in a way, easier to swallow.
So our mission today is ambitious. We need to figure out the path this highly specific, unorthodox theory took to arrive in our modern conversation.
Right. We're going to unpack the historical threads, how the concepts of time travel and future human evolution sort of merged together over time.
And then we'll examine the powerful scientific paradoxes inherent in the extraterrestrial hypothesis. The very paradoxes the TTH is specifically designed to solve.
We'll trace the concepts from, believe it or not, 19th century French literature, move through the serious theoretical physics debates of the late 20th century, and then we'll conclude by analyzing the rigorous scientific skepticism that, well, attempts to completely dismantle the whole idea.
So it's a deep dive into humanity's past and potentially our own future. Okay, so if you're going to propose that future humans are piloting our UAPs, you need two fundamental concepts to be in place.
Two pillars.
First, the possibility of time travel itself, and second, the idea that our own evolution might radically transform us.
You can't have one without the other for this to work.
Let's start with a journey back in time. It's surprising, but the idea didn't really appear in literature until relatively recently.
That's right. I mean, prophecy and looking forward is ancient, but the modern, mechanized notion of time travel from the future to the past, that's thought to have first appeared in published literature in 1861.
A pivotal moment. And the example is so specific. Paris avant les hommes, which is Paris before men.
By the French botanist and geologist Pierre Boitard.
And what was the story?
It features a man who is, for all intents and purposes, sent back to prehistoric Earth. There, he interacts with an ape-like ancestor.
So right from the very beginning, the first instance, it connects time travel with our own evolutionary past.
It does. What makes it so crucial is that connection. It wasn't just a gimmick. It was a device for self-discovery through time.
This theme continued, right?
Yeah, right.
Just over 20 years later, in 1887, another French author, Camille Flammarion, wrote a novel called Lumen.
And Lumen took the idea even further. It featured an alien soul traveling through different worlds and historical periods. So the literary foundation, it solidified really quickly.
Travel through time was now intellectually connected, not just to prehistory, but also to these vast evolutionary and astronomical distances.
Which sets the stage for imagining vastly different forms of intelligence visiting different eras.
Okay, now we have to acknowledge the elephant in the room. The source material is very clear on this. Travel back to the past is almost universally considered physically impossible. The known laws of physics seem to prevent it.
They do. So what keeps the concept alive for the purposes of this hypothesis? The fact that theoretical research exists at all, that provides the necessary sort of scientific cover. While most scientists reject the possibility, some theoretical physicists have explored whether certain exotic yet permitted physics might someday allow it.
And that keeps the idea just plausible enough to function in a serious speculative model.
Exactly.
So what kind of exotic physics are we talking about here?
We're talking about researchers like J. Richard Gott and Ronald Mallet. Gott, for instance, he famously explored the idea of using cosmic strings.
Cosmic strings.
Yeah, hypothetical, immensely dense lines of energy. The idea is you could use them to potentially warp space-time and create a path to the past.
And Mallet.
Mallet's work often involves the theoretical possibility of using immense gravitational fields, maybe created by rotating lasers, to similarly twist space-time into what's known as a closed time-like curve.
So the key takeaway for the TTH is that if you have sufficiently advanced physics way beyond ours, the concept isn't strictly ruled out in all theoretical models.
Precisely. That's the foundation for the mechanism.
But the crucial second pillar of the TTH is the identity of the traveler. If they are from the future, they won't be like us.
Not at all. And this is where H.G. Wells comes in, linking time travel directly to speculative evolution.
Or time machine.
Wells' 1888 novella. It's the crucial foundational work. It is arguably the first modern instance where time travel and speculative evolution are just completely intertwined.
He didn't just send his protagonist forward in time.
No, he showed him a world populated by the Morlocks and the Eloi, our distant, diverged, and, well, somewhat degenerate descendants.
And that instantly conditioned the public to accept that future humanity would be radically transformed.
The message was simple. Humanity is not the endpoint. We are just a temporary stage in a long and potentially very bizarre evolutionary chain.
That theme was picked up by other influential authors who really cemented this concept.
Absolutely. Olaf Stapledon's 1930 epic Last and First Men envisioned billions of years of human evolution, with numerous species replacing our own.
And later, Kurt Vonnegut in Galapagos explored how environmental pressures can lead to really unexpected, strange evolutionary outcomes.
So this whole literary tradition, it created the imaginative space for the TTH to eventually take root.
So if we look at the source material, what are the primary drivers that would alter human evolution enough to create these chrononauts?
The sources identify several powerful interacting forces. One is the inevitable influence of climate change, which could force radical adaptation.
Leading to specialized, maybe non-surface dwelling populations.
Potentially. And then there's the big technological leap.
The singularity.
Precisely. The technological singularity is mentioned. For you listening, the singularity refers to that hypothetical point in time when technological growth becomes uncontrollable and irreversible.
Resulting in just unfathomable changes to human civilization and, crucially, to our biology.
Right. If we merge with AI or just rely entirely on advanced technology for survival, our biological needs and pressures change drastically.
Which leads directly into this third category. Transhuman and posthuman scenarios. What do those terms imply?
Transhumanism often refers to using technology like genetic enhancement and cybernetics to overcome our biological limitations, to become more than human.
And posthuman.
Posthuman is the next stage, where evolution, whether it's biological or technological, has moved us so far beyond our current form that we might be unrecognizable.
Factors like deep space travel could also contribute to this, right? Requiring radical biological modification.
For sure. The time traveler hypothesis basically posits that the UAP pilots are simply us after all these massive technological and environmental shifts have run their course. To understand why the time traveler hypothesis gained any traction, we have to briefly anchor ourselves back in the origins of modern UAP phenomena.
We're talking about the modern UFO era, which really begins in the summer of 1947.
With the Kenneth Arnold sighting.
Right. He described what he saw as objects moving like saucers skipping over water. This sighting became national news almost overnight, and it sparked an immediate and widespread public frenzy.
And the initial explanations were pretty pragmatic.
Yeah.
Secret U.S. or Soviet aircraft, misidentification, maybe mass hysteria.
But within a few years, the extraterrestrial hypothesis, ETH, the idea that these were spacecraft piloted by aliens from other planets, became the dominant fringe explanation.
It did. The problem is, as the decades passed and the abduction and close encounter reports piled up, the ETH ran into a massive, persistent, logical contradiction, didn't it?
A huge one, a contradiction that the TIFF perfectly resolves.
It's the whole reason for the TT-8's existence, in a way. It's a deliberate attempt to solve the most significant evolutionary paradox of the ETH.
Which is?
Why do alleged aliens in abduction folklore and close encounters consistently look human, or at the very least humanoid?
It's a great question. If life evolved on a planet with entirely different gravity, atmosphere, biochemistry, the chance of it ending up as a bipedal creature with 2 eyes, 2 arms, and a head on top should be impossibly low.
Statistically 0, really. And this is where mainstream evolutionary biology actively pushed back. The scientific world recognized this flaw very early on.
Let's talk about the influential work of George Gaylord Simpson.
Simpson, a highly respected paleontologist, published a seminal article in 1964 called The Non-Prevalence of Humanoids.
And what was his argument?
He made a very strong case that the sheer contingency of life on Earth makes it wildly improbable for ET life to evolve at all. And even if it did, the likelihood that it would follow the exact same path that led to humanoid characteristics is, well, it's statistically negligible.
He argued that convergent evolution might produce analogous functions, like wings or eyes.
Right, but not the entire suite of highly specific human features. And this skepticism was shared broadly among biologists at the time. It provided a solid scientific foundation for dismissing the whole humanoid alien idea.
And this critique has persisted.
Absolutely. Simpson's arguments were later cited and deeply analyzed in the 2014 NASA essay collection, Archaeology, Anthropology, and Interstellar Communication.
Which also referenced similar views from other biologists.
Yes, like evolutionary biologist Theodosius Dobzhansky, who also argued against the plausibility of humanoid extraterrestrial life evolving independently.
This brings us to the famous and perhaps most potent thought experiment in modern biology, Stephen Jay Gould's rewind the tape argument.
Yes. It essentially dismantles the idea of the humanoid alien.
So how does it work?
Gould's argument centers on the idea of contingency. He suggested that if we could metaphorically rewind the tape of life back to the Precambrian era and then let it play again, the subsequent evolutionary outcome would be radically different.
The whole chain of random events, asteroid impacts, climate shifts, specific genetic mutations that led to us is so unique and improbable that we are fundamentally an accident.
Exactly. So if we're an accident, then the idea that evolution is somehow programmed or aiming to create a human-like form, what biologists call human-oriented teleonomy,
Is scientifically false.
Precisely. If there's no inherent directionality, then the chances of 2 different planetary environments producing creatures that look similar enough to be described as humanoid is mathematically 0.
Gould's work really solidified the biological consensus. If intelligent life exists elsewhere, it will look truly, well, alien.
It would. So this sets the stage for the TT-8.
Because if the classic gray alien, the large-headed, slender, large-eyed figure, is evolutionarily implausible if it comes from Zeta Reticuli,
Then the only remaining option for its humanoid shape is a connection to Earth.
and that's the logical bridge the TT crosses.
It is. Biologist Jack Cohen and mathematician Ian Stewart, in their book Evolving the Alien, confirmed this impossibility. They asserted that extraterrestrials from a truly alien world just couldn't have evolved a physiology so similar to ours.
The time traveler hypothesis sidesteps this evolutionary problem entirely.
It does. It just argues they look like us because they are us, just evolved. It flips the search from where in space to when in time.
So the idea of chrononaut UFOs, or the time traveler concept, it starts to surface in the countercultural and pseudoscientific literature of the 70s and 90s.
Right, but it needed some philosophical weight to really take hold as a coherent alternative to the extraterrestrial idea.
And that weight came from Jacques Vallée.
Yes.
Yeah.
Vallée, a computer scientist and ufologist, provided a critical early philosophical shift in thinking. He really opened the door to temporal and dimensional explanations.
And this was in his 1975 book, The Invisible College. He had this crucial insight.
He argued that if our understanding of space-time is incomplete, if time and space are more complex than we assume, then trying to ask the geographical question, where do they come from, may be useless.
He famously suggested they could come from a place and time.
That simple reframing, it legitimized the idea of temporal origin in a way no previous theory had.
It's a huge shift, moving the source of the mystery from a physical star system to a temporal era.
And we see other specific references following this philosophical lead, connecting the chrononaut idea to older mysteries. Okay. Authors like Jenny Randles in Time Storms and James Herbert Brennan in Time Travel, A New Perspective. They began drawing parallels between alleged time travelers and these pseudo-archaeological notions of ancient astronauts and ooparts.
out-of-place artifacts.
Exactly. The idea was that maybe ancient mysteries are just technological litter left behind by temporal visitors.
And then, inevitably, the ultimate UAP incident, Roswell, gets woven into this temporal narrative.
It had to. The 1998 book The Day After Roswell, written by Philip J. Corso and William J. Burns, brought a really sensational claim into the light.
What was the claim?
They claimed that German physicist and rocket engineer Dr. Hermann Oberth, who was brought to the U.S. after World War II, allegedly believed the recovered craft from Roswell could have been a time machine.
Now, regardless of whether that's true, that claim powerfully injected the concept of a temporal machine right into the most famous UFO crash narrative.
It did. It further cemented the TT in the public imagination.
All of this brings us to the modern champion of the time traveler hypothesis, the person who gave it its most rigorous biological framework, Dr. Michael P. Masters.
Yes, the biological anthropologist who coined that important neologism, extratempestrial.
Right. And Dr. Masters at Montana Technological University, he explored the model in detail in his books, like Identified Flying Objects.
His core thesis is elegant. He says, take the consistent anatomical descriptions of the gray alien, and instead of asking where they evolved on another planet, ask how we might evolve if we survived a technological singularity and were forced into controlled high-tech environments.
So he's treating abduction reports not as science fiction, but as paleoanthropology from the future.
That's a great way to put it. He's making specific predictions about our descendants' morphology.
What are those predictions based on?
Evolutionary pressures. First, the environment. If future humans live entirely indoors in places with controlled climate, light, maybe even lower gravity,
then the need for robust muscles, skin pigmentation, or standard eyesight just diminishes.
Exactly. That explains the slender, pale bodies. But what about the defining feature? The enormous head and eyes.
Right.
That is addressed through brain growth and the evolutionary phenomenon of paedomorphism.
And paedomorphism, for you listening, means the retention of juvenile physical characteristics in the adult form.
Correct. Think of how infants and children have disproportionately large heads and eyes compared to their bodies.
Okay.
Masters posits that future life will be completely reliant on advanced information processing. That drives increased brain growth and subsequent craniofacial evolution.
So these juvenile features, the large round cranium, the large eyes, might become permanent adult traits.
In his model, the gray is essentially an evolved human baby, a product of technological adaptation. He also suggests diminished features like the nose and mouth, reflecting an advanced system for nutrient intake, maybe bypassing manual eating and robust digestion.
That's a highly specific evolutionary argument, but why? Why would these highly evolved, technologically superior beings risk temporal paradoxes and dangerous travel just to visit our messy, pre-singularity 21st century?
The proposed motives are generally academic, almost quaintly human, actually.
What do you mean?
The primary reason is often framed as historical or paleoanthropological interests. They are studying their origins.
So grad students getting their PhDs in early human societal collapse.
You could joke about it like that, yeah. They're observing us before or during our major global crises. It's the ultimate fieldwork.
And a secondary motive.
Tourism. For beings living in a highly structured, potentially sterile future, the early 21st century with its chaos, its nature, its lack of full technological control, it might be the equivalent of a visit to the wild frontier.
And it's not just a theoretical model. The TTH has been explicitly linked to some high-profile UAP incidents.
It has. British journalist and former Ministry of Defense civil servant Nick Pope notably connected the hypothesis to the famous Rendlesham Forest incident in the UK.
Britain's Roswell.
Often called that, yes. And also the Cabo Valdez case in Chile. He suggested the strange details of these encounters might be better explained by temporal visitation than by stellar travel.
And rounding out the popularization, you have the sensational online claims that fuel these conspiracy narratives.
Oh, for sure. The Huffington Post reported on one prominent online theory involving a U.S. Navy commander, George W. Hoover.
What's the story there?
He allegedly stated that the Roswell incident involved extratemporal humans from the future. And the enduring claim here is that the consistent observation of their near-humanoid appearance strongly suggests a link to our current form.
Implying that they've mastered time and space travel without fundamentally changing the basic human blueprint.
Right. The consistency of that humanoid factor remains the TTH's strongest popular selling point. One of the reasons the TTH gains traction is its fluidity. It doesn't just stand alone, it frequently overlaps with another major alternative explanation for UAPs.
The interdimensional hypothesis, IDH.
Exactly.
So how does traveling through time connect to traveling through dimensions? Aren't those two distinct concepts?
In the context of UAP theory, they are often linked. The IDH suggests UAPs originate from another dimension or a parallel reality.
Okay.
Well, if you consider time itself a dimension, the fourth dimension, then traveling through time requires temporal displacement, which is, by definition, a form of interdimensional travel.
So someone like Dr. Masters, the proponent of the extratempestrial model, he actually considers his temporal model a subcategory of the interdimensional hypothesis.
He does. And for others, like former MUFON director John Ventre or the researcher Harold E. Puthoff, the ability to manipulate space and time is often seen as a package deal.
What do you mean?
If you have the technology to travel across immense temporal distances, you almost certainly have the ability to manipulate dimensions as well. This solves the spatial travel problem and the temporal paradox problem at the same time.
The paradoxes. This is the stickiest part of any time travel theory.
It really is.
The classic grandfather paradox. You go back in time and accidentally prevent your own birth. The TT needs a robust theoretical framework to avoid causality collapsing.
And that leads us to the many worlds interpretation of quantum mechanics, MWI.
A scientifically controversial but explored framework.
Right. It suggests every possible quantum outcome creates a new branch, resulting in an infinite number of parallel universes. So if the time traveler moves from one parallel universe, their home timeline, to another when they travel backward, they avoid the paradox entirely.
So they don't change their past. They just create a new parallel past.
Precisely. They travel back in time, but they land in a different dimension or timeline. The original timeline remains intact, and their actions in this new past don't prevent their own existence back home.
It's a neat, if mind-bending solution. It allows the TTH to be theoretically viable, provided you accept MWI.
Which is a big if, but one that remains within the bounds of physics speculation.
The TTH also offers a genuinely intriguing alternative solution to the greatest cosmological puzzle, Fermi's paradox.
If the universe is infinite, where is all the obvious extraterrestrial life?
Exactly. But the TT flips that, asking, where are the obvious future time travelers?
And the TTH suggests that future humans are here. They are the UAPs. Their absence isn't an absence at all. It's just a failure of recognition.
They're hiding, or maybe adhering to a strict temporal prime directive, or they're using technology we simply cannot categorize or detect as artificial.
And this very idea was entertained by one of the most respected minds in science, Carl Sagan.
He was surprisingly open to it.
In an interview with Nova on PBS, Sagan gave a huge philosophical nod to the idea. Despite his general skepticism, he pointed out that time travelers might be present but unrecognized.
He said we might have other names for them, such as UFOs or ghosts or hobgoblins or fairies.
It's a remarkable line. He didn't dismiss the possibility of time travelers based on their absence. He suggested we might just be mislabeling them using our existing categories for the unexplained.
His conclusion was key. He didn't believe that the fact we are not obviously being visited by time travelers proves the impossibility of time travel.
And that provides immense philosophical encouragement for those who support the TT8.
Culturally, this idea has such deep roots. The audience is already primed for the concept.
It's a pervasive sci-fi trope. I mean, look at the 1987 novel Sphere by Michael Crichton, later a film. The big revelation is that the mysterious deep-sea alien craft
is actually a ship built by humans from the future that accidentally traveled back in time.
Exactly. That plot device brilliantly uses the TT to generate the story's twist. Then there's the 1993 film Official Denial, which uses it directly.
The abducted man learns the aliens are future humans.
Right. And moving to more complex, high-budget cinema, you have Christopher Nolan's Interstellar in 2014.
Which provides a philosophical endorsement of the TT-8 on a cosmic scale.
Absolutely. The bulk beings, these highly evolved entities that created the five-dimensional tesseract and the wormhole, they're ultimately revealed to be evolved future humans.
They are technologically superior entities, existing in a higher dimension, guiding their ancestors to survival.
It reinforces the motive that they are here to help, or at least shepherd, their past selves.
And even in contemporary horror and sci-fi, like Jordan Peele's 2022 movie, nope, the TTH is still referenced directly.
Yeah, mentioning futuristic humans coming back in time to stop us from destroying the planet. The idea is constantly circulating, preparing us for the possibility. Okay, we must now pivot to the rigorous scientific and logical critiques this hypothesis faces.
Right. We established early on that the TT is broadly regarded as pseudoscientific.
And the criticisms are not minor, they strike at the heart of its foundational assumptions.
We have to start with the logical flaws. If the TT-8 offers an elegant solution to the humanoid problem, its reliance on time travel creates an even bigger problem of plausibility.
It does. Astrophysicist Neil deGrasse Tyson, for one, has simply dismissed the entire framework as illogic.
And that illogic stems from what? A reliance on a chain of unlikely events.
Pretty much. UFO skeptic Robert Schieffer criticized the work of Dr. Masters specifically for relying on the belief that time travel is not only possible, but real.
So the critique is that you are stacking two massive, unsupported leaps of faith.
Exactly. First, that UAPs are artificial craft, and second, that time travel is real and currently being used. Remove the foundation backward time travel, and the entire hypothesis, regardless of how well it explains humanoid appearance, just collapses.
This leads to the argument that the entire TTH is unnecessary, even if we grant the possibility of time travel.
That's the stance taken by British astronomer and science writer David J. Darling.
What's his take?
Darling stated that the TT-8, like the extraterrestrial hypothesis, might be equally reasonable in the realm of pure speculation, but it is ultimately highly unlikely and unnecessary.
Because his fundamental counterpoint pushes back on the initial evidence itself.
Right. He argues that there is precious little credible evidence that the observed UAPs are artificial in the first place.
That's a powerful point. If we can't prove that UAPs are engineered craft, then spending tremendous intellectual energy devising a source for their propulsion system and pilots is just unwarranted.
You're attempting to solve a mystery that may simply be atmospheric physics or misidentification. It's the ultimate skeptical critique. Don't hypothesize a complex answer like time travel for a question that might not even be genuine.
Another key line of attack focuses on the potential for cultural contamination. The life imitates art critique.
The idea that our widespread cultural exposure to these concepts might actively taint eyewitness recollections.
And this was specifically used to critique the Rendlesham Forest incident.
It was, by science writer Ian Ridpath. Retired Sergeant Jim Penniston made claims following hypnosis sessions that the craft was a time machine.
Okay.
Ridpath noted that Penniston's claims surfaced around the time the sci-fi film Official Denial, which, remember, featured future humans as aliens, was circulating on video.
So the suggestion is that the sci-fi film provided the narrative structure for his memory.
Potentially. The art provided a plausible explanation for the unexplained, and Penniston's memory under hypnosis may have integrated the plot elements of future humans into his recollection of the real-life incident.
It suggests the hypothesis isn't solving the puzzle. It's creating the evidence through suggestion, a kind of false memory.
Exactly. It raises a massive red flag about the purity and reliability of testimony, especially when dealing with phenomena so deeply ingrained in pop culture.
Finally, we have to return to the practical physics hurdle. Even if we accept the many worlds interpretation to solve the paradoxes, there is a fundamental issue of logistics.
Yes, quantum physicist Fabio Costa highlighted this ultimate practical barrier.
What did he focus on?
On the necessary existence of the mechanism itself. He noted that traveling back in time requires a door, a functioning time machine, to the past. So we asked the key practical question. So people from the future cannot visit us unless someone has already invented a time machine and nobody knows.
Which leads to the logical absurdity of the proposition. The machine, which has to be advanced enough to manipulate space-time, must exist now in our present.
That's the barrier. If these chrononauts are visiting us from, say, 10,000 years in the future, their machine had to have been created and still be functioning in the year 2024 to allow them access to this time.
You cannot travel back in time to the 21st century unless the door was already built in the 21st century or earlier.
And that practical, observable absence of the machine remains one of the strongest, most direct physics critiques against the TT-8.
So we have journeyed through the radical and highly specific time traveler hypothesis. It's a compelling narrative, even if it is widely considered pseudoscientific.
It really is, and we've seen that the theory stands on three main conceptual pillars.
First, the desire to explain the common reports of humanoid sightings, which elegantly bypasses the evolutionary impossibility of ET humanoids.
Second, the theoretical possibility of time travel offered by physicists like Gott and Mallet.
And third, the detailed scenarios of future human evolution put forth by authors like Wells and anthropologists like Dr. Masters.
What's truly insightful about this model is how it just flips the narrative. It takes one of the most persistent mysteries of the UAP phenomenon, the strange resemblance of the pilots to us, and reframes it.
It's not a cosmic coincidence.
But a simple family reunion. It connects everything back to humanity.
And as we discussed, this hypothesis offers a unique, albeit speculative, solution to Fermi's paradox. It suggests that the reason we see no evidence of future time travelers is that we simply aren't recognizing them, or they're just too adept at hiding.
Which brings us to our final provocative thought for you to chew on. Carl Sagan, in his remarkable open-mindedness, speculated that time travelers might be present, but simply unrecognized.
Having other names like UFOs or ghosts or hobgoblins or fairies.
So if we take this premise seriously, that future humans are operating here, discreetly using technology that looks impossible to us, what might they be doing right now?
What everyday modern phenomena that we currently dismiss as natural, unexplained, or even just quirky coincidences might future humans be subtly utilizing, monitoring, or altering today? And what temporary side effects might those activities be leaving in our present?
Perhaps the strangest things happening in your life right now are not random at all.
Thank you for joining us for this deep dive into the Chrononaut UFOs. We'll see you on the next deep dive.